Okay, folks, welcome back to Klein's Calculus. After I figured out from my last video, I forgot to square that cosine. That's the secant squared. So to get to the right slope, we need to take 2 times 1 over the cosine squared of 2 squared minus the tangent of 2. And then when you find that, you've got to divide it by 4. So there is my slope. And I'm going to store that as b. Now I have those things in my calculator. I have a point, I have a slope. So I can write down for my tangent line the slope times x minus 2, that's the y coordinate or x coordinate of my point, minus this, my y coordinate of my point. And when I simplify it, I've got this, and I can take, since this is the slope, I can say, and I know that's b, so I can say 2 times b, and then plus a, and I'll get, okay, should have been minus a, and then you would get to the right answer. Obviously, you got to watch your signs here. Now, for the normal line, I need to find my perpendicular slope. I stored my slope as b, so I know the perpendicular slope is the opposite reciprocal, so it's negative 1 over b, so I can say negative 1 divided by b, and I know the perpendicular slope is about negative 0.251. So now when I write this equation, I'll write y equals negative 0.251 times x minus 2 minus 1.093. And when I distribute this, negative 0.251x, a negative times a negative is a positive, and I've got that right here in my calculator. So I can take this, and I know it's going to be times my negative 2. So I've got plus 0.5025 minus 1.093. Well, that's a. So I'm going to say that minus 1.093. I could have done it as a too, but this is going to be fairly accurate also. And I end up with plus minus 0.5905. And you only have to go to 3 decimals, but you can go to 4 if you like. So that's how you're going to find these tangent and normal lines. Find the point. And if you have to put it into your calculator and store it, that is fine. If it doesn't come out even, that's your best way to do it. Don't round until the end. Now the last thing I want to talk about here is finding a trig second derivative. Find y double prime if y equals the secant of x. Well, we know that y prime equals the secant of x tangent of x then, right? We learned that in the first part of the video. So to do the find the second derivative, we're going to have to use the product rule. We've got u and v, and we know y double prime is going to equal the first times the derivative of the second plus the second times the derivative of the first. So I'm going to write down my first, the secant of x, and the derivative of the tangent is the secant squared of x, plus, now I'm going to take the second, the tangent of x, and then the derivative of the first. Derivative of the secant is the secant of x, the tangent of x. And you can just write them all out like this in a row. And now I'm going to take y double prime, and that's the secant cubed of x plus the secant of x times the tangent squared of x. So I can write it this way as my final derivative. Now, you might wonder, secant is 1 over the cosine. Maybe you'd say, hey, I wonder if I could simplify that anymore. And you might write it out, well, you know you can't do that. But secant, 1 over the cosine, and tangent is the sine over the cosine. And when you looked, you'd say, no, there's nothing I can cross out, so you know what? That's as good as it gets. But it's always worth a look when you're looking at these trig things. And when you do look at your answers in the back of the book, sometimes you're going to see that. You'll get to an answer, and they'll have a little different one. That doesn't mean you're wrong. It means maybe they simplified to a different level. So be aware of that, and keep in mind that when you're finding second derivatives of trig functions, you do end up with the product rule quite often. So enjoy the calculus. Till next time.